errors and measurement. Now you will perform lot of experiment in your life. So you will be taking lot of readings, and when we take any reading, we end up making errors. We end up having errors. So now we'll learn how to take care of that errors. So error are of three types: mean absolute error, relative error, and percentage error. Why will there be error in our experiment? When we do any experiment and we take reading, why is there any error in the reading? See, there will be some weather factor. There will be some human factor, like you are tired, you will not like to do it properly, you will not look at it properly. Yes. Then there is machine, the machine might be faulty. Yes. Fine. So all these are the reason for error. Yes, sir. Instrument error, that machine is faulty. Human error, that you don't want to do experiment, you are tired, you are not looking at it properly, you are just doing for the sake of doing. That is human error. Yes, sir. Fine. Then there are climatic factor. Suppose you are measuring the density of water and the temperature changes, the density will change. Yes, sir. Now the errors are of different types: mean absolute error, relative error, and percentage error. So we'll understand what does this mean. Yes, sir. Mean absolute error. So first let's understand mean absolute error. So there is an experiment for this. Suppose we do an experiment. The aim of the experiment is to measure the length of Fardeen's mobile phone. So I asked Fardeen to measure the length of Fardeen's mobile phone 4 times. Suppose if I ask you to measure your length 4 times. So Fardeen will come up that the measurement has given me the result as 12.8. First time I measured it. Second time I measured it, I got it as 12.7. Again I measured it, I got it as 12.4. I was not feeling very nice. I was tired because of constant measuring. So I just took the scale and measured it like this. I got 12.4. Then again I measured it. I got it as 12.1. Fine. So these are the 4 measurements that you come up. You say, I have measured my mobile phone 4 times and these are the readings. Okay, Fardeen? Yes, sir. So now we define true value. What is the actual value or what is the actual length of your mobile phone? We define true value. True value means actual length of your mobile phone. This is the length measured by you, but we want the true value, because when we will get the true value, then only can we say what is the error in your measurement. Yes. So true value is sum of all measurement divided by number of measurement. ठीक है, ये होता है true value. So if you measure your mobile for 10,000 times and you will add all the values and divide it by 10,000, you will actually get what is the actual length of your mobile phone. Yes, sir. So the true value here. So the true value of this is 12, 12, 12, 8, 7, 15, 4, 19, 20, and this is 12, 50. This is. So 50 divided by 4. 50 divided by 4 is 12.5 centimeter. So I get the true value of your reading as 12.5 centimeter. Yes. So error in your reading is 0.3 centimeter. Error is defined as reading minus true value. 0.3. In the second one, the error is 0.2. In the third one, error is minus 0.1. In the fourth one, the error is 0.4 minus. Then we define absolute error. Absolute error is the positive value of this 0.3, 0.2, 0.1, 0.4. This is absolute error. So mean absolute error. Mean absolute error, Fardin, is sum of absolute error divided by number of terms. So many terms I have defined: true value, error, mean absolute error. So mean, we have sum of that is 0.5, 1.0 divided by 4, 0.25. Yeah. So 0.25. So I'll not take it as the answer.
Yes.
Why? Because this is more accurate.
Yes.
This is more accurate. I have to take it as rounding of 0.2 because I'm dropping 5 and 2 is even. So I'll simply write 0.2. So this is the mean absolute error.
Yes, sir.
Understood how to find out mean absolute error?
Yes, sir.
So this is the step to find out mean absolute error. Now see further, relative error. Relative error is defined as mean absolute error divided by true value. Fine. So from the previous question, I can say that the mean absolute error is 0.2 divided by 12.5. So this is 2 by 125. This is relative error. Then we have percentage error. Percentage error is relative error into 100. That is 2 upon 125 into 100. This is 2 into 125 into 100. So this is like 5 times, this is 4 times, this is 8 by 5. This is 1.6%. So the error in our measurement is 1.6%. So when, according to you, when you have measured those measurement and given me, the error was 1.6% only. Okay, Fardin? Now, combination of error. Suppose this is a land. I ask you to measure its length and I ask you to measure its width. So when you measure its length, you will have some error. And when you will measure its width, you will again have some error. And if I ask you to find out the product L into B, the answer will also have some product. If I ask error, if I ask you to subtract it, there will be some error. If I ask you to add it, there will be some error. If I ask you to divide it, there will be some error. If I ask you to raise L cube or B to the power 5 or anything, it will, the resulting number will also have some error. So how to find out the error? You have found out the error in length, you have found out the error in width. But now you are multiplying them, adding them, dividing them, taking power of them. How will the error change? This is what we are going to study now. Okay, Fardin? So, in addition and subtraction, error gets added up. In addition, subtraction, error gets added up. What I mean by this? Suppose you have a length, you have length 12.3 plus 0.1 plus minus 0.1. So this is the true value, this is the error. Or say this is the reading, this is the error. Similarly, if B is equal to 5.6 plus minus 0.1, so this is the error and this is the reading. So if you add L plus B, so this will be simply 12.3 plus 5.6 and the error will be plus minus 0.1 plus 0.1. So answer will be 17.9 plus minus 0.2. Okay, Fardeen.
Yes.
Suppose if you want to subtract it, L minus B if you are doing. So this is like 12.3 minus 5.6 plus minus 0.1 plus 0.1. Error will not get subtracted. Error will, even if it's subtraction, error term will get added up. Because it doesn't mean that when you subtract, the error will reduce. The error will remain same. So this is 12 minus 5 is 7. And this is 0.6. So this is 6.7 plus minus 0.2. Understood, Fardin? Did you get this?
Yes.
Simple thing. Error will get added up.
Yes.
Simple. Error gets added up. Now, in multiplication and division, relative error gets added up. Relative error gets added up. Suppose we have L is equal to 4.0 plus minus 0.2 and B is equal to 5.0 plus minus 0.2. So relative error delta L by L, this is 0.2 by 4 and delta B by B, that is 0.2 by 5, because true value, error divided by true value is relative error. So if you multiply L into B, so this will be 4 into 5 plus minus, fine, plus minus the relative error का sum. So delta मान लेते हैं L into B is area. So delta A upon A is delta L upon L, delta B upon B. मतलब एरिया का जो एरर होगा ये इन दोनों का सम होगा, रिलेटिव एरर का. In power, the relative error gets multiplied by the power term. What I mean, suppose you have y is equal to x to the power n. Y is equal to x to the power n. And x is 4 plus minus 0.2. And you have to find out the error in y. So delta y by y, error in y is n times delta x by x. That is n into 0.2 upon 4. ये हो जाएगा एरर. बस एक लास्ट चीज, मेजरिंग इंस्ट्रूमेंट एंड लीस्ट काउंट. ये बस एक आखिरी चीज मैं बताना चाहता हूं कि कोई भी इन एनी इंस्ट्रूमेंट, if you want to take a measurement, the least count of that instrument is taken as absolute error. The least count, this sentence here, this represents least count or the absolute error in the measurement. The error in the measurement of an instrument is equal to the least count of the instrument. What we mean by least count? So least count is like the smallest measurement that can be done. You have got ruler in your home. To take measurement. If you look into that ruler, which is the smallest measurement that you can take using that ruler? What is the smallest measurement that you can take using that ruler? 0.1 millimeter is the smallest measurement that you can take.
Yes.
Because this is 1 centimeter, this is 2 centimeter, and in between them there are 10 units. Fine. So this is the least count. This is called as least count, smallest measurement that you can take. Understood, Fatih? Understood? So for instruments, absolute error, you always take as least count.